Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from integrals, right? So in this lecture we are going to solve this important integral which is from 0 to 1, and the integrand is log x raised to n, where this n is a natural number, right? So n belongs to the set of natural numbers, and here we have logarithm of x, and here log x is the natural log, that is with base e, right? So we can also write log of x as ln x, right? But we'll prefer this notation, right? So let us start and let us see how we can solve this important integral with the help of gamma functions. So let us take this integral as I, right? And let us make the substitution as y is equal to log of x, right? So when we take y is equal to log of x, it implies that x is equal to e raised to y, right? Okay, now if we differentiate x with respect to y, then we have dx over dy is equal to e raised to y, right? Because the derivative of e raised to y with respect to y is e raised to y. So now we have dx is equal to e raised to y dy, right? So for this dx we have e raised to y dy, right? Now here the limits vary from 0 to 1, right? So when we have the lower limit as x is equal to 0, then the value of y can be obtained by taking x is equal to 0 in this relation. So when x is equal to 0, then y is equal to a log of 0, right? And log of 0, it tends to minus infinity, right? And similarly here when we take x is equal to 1, then y is equal to log of 1. So we have here log of 1 is equal to 0, right? So when x goes from 0 to 1, then y goes from minus infinity to 0, right? So now we can write this integral I in terms of y as minus infinity to 0. Then log x is replaced by y, so we have y raised to n, and dx is e raised to y dy, right? So now we have this integral, right? Now to move further, what we will do, we'll again make use of the method of substitution, right? So let us further substitute y is equal to say minus t, right? So when we take y is equal to minus t, then here we have e raised to minus t, right? So why we are making this substitution? Because we want to convert this integral into gamma function, right? So we have to take here y is equal to minus t. So dy is equal to minus dt, right? And let us change the limits accordingly, right? So here see y varies from minus infinity to 0. So now let us take t is equal to minus y, right? So when y is equal to minus infinity, or in other words, we can say that when y tends to minus infinity, then t tends to negative of infinity, because here we'll take y is equal to minus infinity, so that is positive infinity, right? So when y tends to minus infinity, then t tends to infinity. And similarly, when y is equal to 0, then obviously t is equal to minus 0, that is equal to 0, right? So now we can write this integral I in terms of t as integral. Here we have infinity, here we have 0. For y we can write minus t, and this is raised to n, and we have e raised to minus t, and for dy we can write minus dt, right? So now to neutralize this negative sign, let us interchange the limits, because we know that a to b f of say t dt is equal to negative of b to a f of t dt. So when we interchange the limits, then we put a negative sign before the integral sign, right? So we can neutralize this negative sign by interchanging the limits. So I is now 0 to infinity. We have minus t raised to n and e raised to minus t dt, right? Okay, now let us take this or we can rewrite this integral as 0 to infinity minus 1 raised to n t raised to n e raised to minus t dt. So now we can take this minus 1 raised to n outside the integral, and then we can write 0 to infinity. T raised to n can be written as n plus 1 minus 1, right? And here we have e raised to minus t dt, right? So now we have written this integral in this form, and we can easily see that this integral is gamma of n plus 1. Now viewers, see gamma of n is defined as 0 to infinity t raised to n minus 1 e raised to minus t dt, right? So this is the Euler's integral. So gamma of n is defined like this: 0 to infinity t raised to n minus 1 e raised to minus t dt, right? And here we see that for this n we have n plus 1, right? And remember, n belongs to the set of natural numbers. So now this integral I is given by minus 1 raised to n, and here we have gamma of n plus 1, right? So the value of this integral is minus 1 raised to n gamma of n plus 1, where n belongs to the set of natural numbers. So viewers, we can also express this result as I is equal to minus 1 raised to n, and gamma of n plus 1 can be written as n factorial, right? Because when n is a natural number, then gamma of n plus 1 is equal to n factorial, right? So now we can write the value of this integral equal to minus 1 raised to n and factorial n, where n belongs to the set of natural numbers. So now let us quickly find out the values of these two integrals with the help of this result, right? So in this problem we have 0 to 1 log x raised to 4, and 4 is natural number, right? So the value of n is 4. So the value of this integral can be written with the help of this result. So we have minus 1 raised to 4, and then we have here 4 factorial, right? So minus 1 raised to 4 is positive 1, because this is even powers, and 4 factorial is 24, right? So the value of this integral is equal to 24. Now similarly we can find out the value of this integral. Here we have 0 to 1 log x raised to 10, and 10 is a natural number, right? So the value of this integral can be calculated with the help of this result. So we have minus 1 raised to 10, and here we have 10 factorial. Minus 1 raised to 10 is positive 1, and we have 10 factorial. So this is simply factorial 10, right? We can calculate the value of 10 factorial.